There we go. All right, well, welcome. Thank you for joining me today for a very brief, it will be about half an hour uh, online opportunity to talk a little bit about curriculum. And the way I'm going to do this today is I'm going to walk you through the process I went through in order to prepare for this. As I was thinking about things that I've already done when I in the past with old grade 4 curriculum, and how do I take that without starting from scratch, but take that and look at my outcomes of the new curriculum, look at my assessment and things like that. So like I said, I'm going to walk you kind of right from the beginning, and I'm going to share all of these documents with you afterwards so that you've got access to all of that. All right, so the first thing I did was I thought about what outcomes do I want to deal with? And one of the easiest ones is the multiplication, because we've already done multiplication lots in grade 4. So then I thought, okay, I use multiplication and I always use the area, not a problem, Dave. I always use the area model, the array model, in order to talk about multiplication. So what other outcomes might there be in the new curriculum in order to connect with those? Because you're going to get your biggest bang for your buck, going to save the most amount of time in the school year, and you are going to help students see relationships and make connections and look for patterns, the more outcomes that you have that connect together. So what opportunities are there in our curriculum to do that? So I'm going to share, I've got a little document camera here, so bear with me while I switch to project my document camera. Okay, so I know it's not the greatest quality, it's kind of dark in here, but I went through and I found 4 learner outcomes that I thought kind of fit quite well together. So I looked at students explain properties of prime and composite numbers using multiplication and division. So that's a really nice connection there. Students interpret and explain arithmetic and geometric sequences. Equations express relationships between quantities, and students interpret and express area. So then after I chose my 4 learner outcomes, I went through and asked myself, all right, not all of the cusps within that really worked well together. So I went and I just bolded the ones that I felt were a good, strong fit, not a soft fit, not a maybe fit, but a good, strong fit. And I wanted to live in the world of strong fits. So you'll notice that when I take a look at arithmetic and geometric sequences, I didn't include this section at all. Let me just back up there a little bit. This row of understandings, knowledge, and skills and procedures at all, because I didn't think it was a good fit. But there were parts of the other one that kind of fit in there that I could be deliberate about making connections to. So it's not about trying to hit all of the cusps, because as well as that, there's not all of the cusps are really good for assessment. You'll see things like investigate, and investigating is a hard piece to assess. So I tried to be thoughtful about it. As I went through, I bolded some as I made connections, and I unbolded some as I found that they weren't a really good fit there. So that's where that was my second step, to figure out what learner outcomes and what cusps really went well together, and allowing myself the flexibility in order to adjust as I develop things. So then I thought, okay, let's do some lesson planning. What would be a great way to start this process? So as always, you know me, I believe in starting with concrete. So I took the same lesson I've done in grade 3 and the same lesson I've done in grade 4 and in grade 5 in relation to multiplication. Now in grade 4, you're expecting kiddos to already know multiplication up to 10 times 10 now, according to the new curriculum, but we also know with the new curriculum, they may or may not have those all mastered at this point in time. So I'm going to provide lots and lots and lots of opportunities through this unit of study for kids to practice multiplication facts. And if I'm finding they're struggling with certain ones, like they're really struggling with 5s, I'm going to focus and choose a lot of questions that give them opportunities to practice with 5s. But for now, I'm just going to start way back in the beginning, something they should have seen in grade 3, because the lower we start, we can gather all of our kiddos at their level of understanding, and we can move them all forward. And they're all going to could possibly move at a different rate, and that's okay. So I'm going to give students tiles like these. These are just 1-inch square tiles. These ones are double-sided. I always call them integer tiles. We actually gave every kindergarten, grade 1, grade 2, and grade 3 teacher in the division some of these tiles last year, depending on what grade level they were at. Grade 3 got more, kindergartens got less. So if you have K-3 in your school, you have these tiles in there in your school. Your grade 3 teacher would be the best person to ask about that. But we do have some 1-inch square tiles in IMC. We've got a big bucket full of them. They're not double-sided like this, but they're a little bit thicker, and they'll do the exact same thing. Because the purpose of this is not to worry about the double-sided, whereas K-3, there's lots of opportunities for them to use the double-sided. So what I would do is get kiddos to count out exactly 6 tiles, and then just build a rectangle using your 6 tiles. So the kiddos might build a rectangle like this. And the only rule is that there can't be any empty spots. You can't do that with only 6 tiles, but later on when they have more tiles, they can't do something like that. That would break it. It has to be a filled-in array using exactly 6 tiles. So a student builds a 2x3 array. And another student might build an array that looks like this one. Another student might build an array that looks like this one, and so on. So it's an opportunity for students to see rectangular arrays built with their 6 tiles. And then it's an opportunity for us to talk about the community property. Because you'll get kiddos who build this array, and then you'll get kiddos who build this array, and then the conversation can center around, are those 2 arrays the same? In PLCs in the past, we've talked a lot about the same. We tend to think of that as exactly the same. And those aren't exactly the same. They're very similar. And if all I do is turn my head, so if I imagine turning my head to see it from a different view, I would see the other array. So I would count these 2 arrays. This would be one unique array. Because if all I do is turn my head or turn the array and I can see the other one, I haven't changed anything else, we'll count that as one array. They're not exactly the same, because 2x3 versus 3x2 can have 2 very different contexts in there, but for these purposes, we'll call them one unique array. And it's important to talk to kiddos about the differences between a 2x3 and a 3x2 array. But for our purposes, they're good. And you might be wondering, well, is this the 2x3 or is this the 2x3? Which one's the 2x3? It really doesn't matter. Certain contexts, this will be the 2x3, certain contexts, this might be the 2x3, and it's all good, as long as kiddos are flexible. So then I might say, well, what is the area of this rectangle? Well, if they haven't talked about area before, they might not be sure. So you can actually introduce it in this situation right off the bat about how each of these tiles is 1 square unit. Why square? Well, because it's a square. And if this is 1, what's the length of this one? It's also 1. So it's 1 square unit. And area, we talk about how many of those square units are there. Well, there are 6 of these square units. And then what I can do is I can trace this on a piece of paper. I can move this apart and talk about I needed 6 of these square units in order to cover that rectangle that I created. So it's an easy way to start slipping in the conversation around what area means as it relates to square units and covering up space in time. So we know that the area of this is 6. I can ask what are the multiplication statements that fit with this, and a student might say, well, I can see in here 1 3, 2 3s. So 2 3s is equal to 6. Another student might say, I see 1 2, 2 2s, 3 2s. 3 2s is equal to 6. Now the other piece of this is I have to remember to start with not the answer, but the overall area first. So when my area was 6, what could my multiplication statements be? Well, it could be 2 3s. When my area is 6, my multiplication could be 3 2s. So I want to make sure students see all of those all together. I could also throw in some division right away. So I've got an area of 6, and one of my dimensions is 2. what's my other dimension? So I can start throwing that in there as well. What are my side lengths of this rectangle? Well, I've got a side length of 2, and I've got a side length of 3. If it was the other way, I still have a side length of 3 and a side length of 2. It doesn't matter which order I do it in, I can still see those. Now, after they've done that, what other rectangles can you build? And I'm only looking for unique rectangles, but you're always going to create the multiplication statements all the way. So then the other unique rectangular array would be this one, 1 6 or 6 1s. And the other one that matches this one using the commutative property, of course, is here, 1 6 or 6 1s. And then on paper, we can record all of those as well. So when students are done, we've got 2 by 3 is 6, 3 by 2 is 6, 1 by 6 is 6, 6 by 1 is 6. In mathematics, we should always be asking, what patterns do we see? So then students should have an opportunity to look for patterns in here. They might say there's always, if there's a 2 by 3, there's always a 3 by 2. They might say, if I go from 1 by 6 to 2 by 3, I doubled the 1, but then my 3 halved. Or I doubled the 1 and my 6 halved. Sorry, I went the backwards on that one. So I can see that relationship that goes that way. Lots of opportunities there to play and explore patterns. One of the other things I want them to see is that no matter what, it was always 6. I always had a total area of 6 because we're talking about conservation of number, which is a grade 1 outcome. So it doesn't matter that I took those 6 and I went from this array to this array. I didn't add any, I didn't subtract any. It is simply a total area of 6, which is awesome. And you'll see right away that which kiddos have that conservation of number and which ones don't. Because if they don't, you're not going to be able to move forward. Now, I can then do that exact same process with 12 tiles. What are your arrays that you can build? What are the dimensions, side lengths of your rectangles? How are those connected? What patterns do you see? What relationships do you see? And so on. So as you're going through this one, and I already have these ones written out, one of the things kiddos might wonder about is even numbers versus odd numbers. They might notice that every equation has at least one even number. Why do you think every equation has at least one even number? Could it have 2 odd numbers? And so on. So playing with that is an opportunity to talk about patterns and relationships with numbers as well. After I've done that, then I might give students a blank multiplication table. I might do this after I did the 6 tiles, or I might wait to do this until after they've had a little bit of experience and I have them try build rectangular arrays of 6 tiles and 12 tiles and so on, and then come back to this one here. But what I want to do is give students a blank multiplication division table and say, let's put this array, this 2 by 3 array, onto our multiplication table. Well, that's right here. And I might use pencil crayon or a marker to outline that. When I look at this, can I see the 2 3s? Can I see the 3 2s? Why do we write the number 6 there? And so on. Okay, what other arrays did you see? Well, I saw a 1 by 6. And I might use a different color pencil crayon here. Do you see the 1 6? Do you see the 6 1s? Why do we write the number 6 here? And repeat that with this one, and repeat that with this one. So that students can get used to using a blank multiplication table rather than a filled-in multiplication table where all they do is this and they have no connection between why these actually make 6. So another nice little thing in order to do that. So then I've done 6 tiles, I've done 12 tiles. Then I might say, okay, you're going to use 15 tiles this time. But before you build, I want you to decide, do you think you're going to get more arrays than you do with 6 tiles? Do you think you're going to get more arrays than you do with 12 tiles? And get them to do some prediction in there. You think you'll get the same number of arrays? and so on. How will you organize yourself so that you know you found all possible situations, all possible solutions? So putting that in the student's hands is important. Do you think there will be more side lengths, less side lengths, and so on? After I've played with that, and students have had lots of opportunities, I might say, okay, we're going to build an array of 60 tiles. And I'm going to make one of my side lengths 2. What do you think the other side length is? And now you are starting to play with numbers that are above the expectation of mastery, but then they can start fiddling with it. And you might not start with 60 because it's a really big number. You might go to a number you just haven't done yet. So 2 by something is 18. Because you haven't built 18 tiles. What do you think this one's going to be? What do you think the other side length is going to be? How will you figure that out? So now you're doing algebra with them, and you're using things that they've already done in order to figure that out. I might say, so in this multiplication equation that's used to describe a rectangular array, what do you know? Well, I know area is 18. I know a side length of 2. I know a side length of 9, and so on. So putting that in the hands of kiddos to play with that. And this, I did this really briefly, about 15 minutes, but this is something you would do over multiple days. And they might only take 10 minutes to do, and then you can do other stuff with other learner outcomes in the day. But this is an opportunity for students to become more flexible with their thinking around the smaller arrays. So then what I did, let me just switch my, I think I'll have to switch my screen here. Then what I did was ask myself, how can I go about recording what students have demonstrated? So when I'm looking at my outcomes, when I'm teaching these lessons, I'm going to be doing very, very specific outcomes. I'm not going to be looking at all the outcomes that I bolded in the beginning or all the cuffs. But I'm going to be watching the classroom for very specific ones related to this particular lesson, portion of the lesson. So I created this Google Sheet, and I'm going to give you guys a copy of this, and it has all of the outcomes in here for grade 4. And there's a coding system in here. That's for eventually, when we get to Power Teacher Pro, we might need this coding system. But you can see all the outcomes. You can see just the number outcomes, just the algebra outcomes, and so on. But I'm going to go to the Create tab, and I'm going to make a copy of this. And I'll just call it L1 for now, because this is my lesson. And this is step 1. So I'm just going to call this step 1, concrete, building numbers with tiles. Okay. And then I'm going to, this is the first outcome I'm looking at is students interpret and express area. So students interpret and express area. There it is. So I'll just pick that one. And then I ask myself, what are the cusps? You'll notice that turned pink just to make it stand out. What are the cusps that go with this? What were the ones I was deliberately focusing on teaching it and deliberately looking for as the students were working? So one of them was area is a measurable attribute. One of them, oops, I went too far, sorry. One of them was an area remains the same. Oops. Click on it. And the other one was visualize and model the area. So if I were to print this, and this is set up to easily print on legal paper, you'll just have to play with your page breaks. And if I type my kiddos' names in here, it will automatically put them at the top of every page in case it runs across pages. If you're only printing on letter size, you can just highlight up to Q. What this does is allows me to have a little clipboard, and as I'm talking to a kid or asking kids questions or watching what they're doing or listening to conversations, I can actually put in what's their level of understanding for this particular cusp. What do I see right now? And you'll notice it's quite long, it's quite tall. So I'm going to print small so that I could put in multiple pieces of evidence. So I might put in, ooh, limited, but you know what? Today was the first day. Maybe even the first day I'm not even going to look at it. Today's the third time we're trying it, they're limited. And then in a week, I'm doing something similar again. Oh, they're satisfactory now. Great. So I'll neatly cross out limited so I can still see it and write down satisfactory. So I'm always using the most recent evidence. So I can put these in here. And when I'm done, overall, I can then come up to the bigger learner outcome and then use all of this data to figure out where are they overall in this learner outcome. So I can use the pieces of their understanding, how they're doing for skills and procedures, and the knowledge that you're demonstrating in order to figure out where they are overall in the learner outcome, because it's the learner outcome we need to report to parents. So what let me just switch back to my other screen so you can see it again. And I already have that document completely created for this entire lesson. So you don't have to recreate it. I will stick it in that Google Sheet when we're done today. All right, so this is just coming up. So this is what it would look like if I were to print it out. And what I did was I set my page breaks so that all of my steps would be on a different set of pages. So you've got that to keep track of. But I always set it up for whatever the step is. We just completed step 1. That's all going to be in one section. And then the next steps will be in later sections. And they'll have their own pages just to make it a little bit easier for me to see. So then I took step 2 and said, okay, what's the next thing that I'm going to do? I've assessed them on the basics. That was grade 3 stuff. They should be good on that. Maybe I don't need to spend much time on it, or maybe I need to spend more time on it because they need it. So that's my opportunity to really bridge those gaps from grade 3 outcomes. So then I can move on to step 2, and this is new. I'm going to introduce vocabulary factors. So then on the board, what I can do is I can just say, and I've got a PowerPoint or a slideshow for this. I can say, well, with 6 tiles, what were our dimensions, our side lengths of the tiles? Sorry, there should be 6 tiles. Well, I can make one with a side length of 1, side length of 2, a side length of 3, and a side length of 6. So 1 and 6, and a 2 and a 3. With 12 tiles, I could build rectangular arrays with those side lengths. With 15 tiles, I could build rectangular arrays with those side lengths. So what do all the numbers represent? Well, they're the side lengths of the rectangles that were built. Well, here's a new word that we need to learn in grade 4. See if you can figure out what it means from these examples. So the factors of 6 are 1, 2, 3, and 6. The factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 15 are 1, 3, 5, and 15. What do you think factors means? So they take a moment to talk about it, figure it out on themselves, talk about it, start to formulate a definition. Why do they all, 6, 12, and 15, why do they all have a factor of 3? Well, that's because you can build an array of 6 tiles with a dimension of 3. You can build an array with 12 tiles with a dimension of 3. You can build an array with 15 tiles with a dimension of 3. So you can build each of those with dimensions of 3, with a factor of 3. Why does only one have a factor of 5? Well, that's because only one of these can be built with a dimension of 5, and when the other one's a natural number. Now they can use a Freire model in order to really define their understanding of factors, essential characteristics, examples, non-examples, definition in their own word. And then after that, instead of saying side lengths or dimensions, we're going to talk about factors. And always bringing it back to a factor is going to be related to the dimension of a rectangle. Now let's do 18 tiles. I want you to write the multiplication statements and the factors of 18 tiles. So all I've done is add one more little thing in the next step. I can give them that same 2 by something is equal to 60, but this time they're going to use the word factors instead of side lengths. I might give them an array like this already built and say, how can I use that to help us determine the factors of 12, and so on. in the document, when you get it, you'll also see there's additional learning opportunities. I've linked a grade 4 worksheet, unit 4, factors and multiples, where it includes practice opportunities using dice and cards and hundreds charts in order to continue with that practice. I've also included an assessment or discussion question, things that I can ask kiddos to help me determine if they understand those outcomes that I'm looking for. And the outcomes that we're exploring this time, and I know it's really blurry, but you'll get this, they can explain factors can compose the same product, a factor of a number is a divisor of that product, and determine the factors of a number. Notice I'm always putting the learner outcome at the top as well, so that I'm reminded that this is all helping to build up to their overall understanding of learner outcome number 3 for numbers. Learner outcome, or step 3. So again, this might happen in another week or so, but I'm going to introduce square numbers, which is literally just saying basically, let's build 9 tiles. What do you notice about 9 tiles? Well, 9 tiles, we can actually build a square with them, which we couldn't do with any of the other numbers. Well, and then it's literally a square number is just when you can build a square using those tiles, it's a square number, which is really interesting. And what are the dimensions of the square number? Well, 9 is 3 and 3. Well, what about 4? 4 is 2 and 2. And then they can start playing with square numbers. And in the lesson, and going really quickly because we only have a few minutes left, but in the lesson it says, what do you think about these ones? Are they square numbers? Are they not square numbers? How do you know if they're square numbers? And the next lesson or set of lessons is prime and composite. And again, it's really simple about, there were some special numbers. 7 was a unique number. 11 was a unique number. What makes 7 and 11 unique? Well, you could only build one unique array with it. Absolutely. The numbers where you can only build one unique array for it, that's has a special word for it. It's prime. And the other ones where you can build an array different ways, more than one unique array, those are called composite numbers. And I've included in here at the back of this booklet a word wall, because I'm trying to be thoughtful around what we learned in PLCs about, or sorry, word maps. There's prime, that you can talk about prime, and there is compose. So you can actually talk about the word sums that go with pose. So that's all in there, so you can play with that. And then the other thing that I included in here, this is the prime and composite one. There's a prime number maze for some practice. There's some composite tasks. Open middles are great tasks that you can do with kiddos to differentiate different levels. And then I included the assessment. That's in uncovering student thinking about mathematics in the Common Core grades 3 to 5 that I told you your school will have somewhere. It's page 41, and then here's a brief description of what that might look like. Again, that's a formative assessment one that you could do with kiddos, or you could even do it as a summative. And then the last one that I had in here that I looked at was step 5, looking at common factors and greatest common factors. Again, really simple, connecting back to everything we've already done. We already actually talked about common factors when we looked at this, and we said, well, why does this have 3s in all of them? Well, because you can build an array with the side length of 3. You can build an array with the side length of 3, and you can build an array with the side length of 3. So 3 is common, a common factor to all of these. So if I'm looking at 6 and 12, what's common? 3 and 3, 2 and 2, 1 and 1, 6 and 6. What's the largest one that's common to both? 6 and 6. What about these two? What's common between these? What's common between these two? And just get kids to play without actually teaching something new. You're just building upon everything they've already done up to that point in time, and then telling them to do it. And the last one I'm not going to go through today is the multiples. But multiples really just connects back to skip counting, which we don't want to say multiplication is skip counting, but multiplication is related to skip counting. So this one is building upon that. But again, we're going to skip count and so on. And what's common? What's the first one you hit if you're skip counting by 6 and 12? Then I've got application numbers higher than 20, and then I've got in here a couple learning experiences. This first one, Joe Bowler's number visual, you can see that. Joe Bowler's number visuals activity is amazing. I've used this lots and lots and lots, but it's a little bit more pictorial, so I do that afterwards. There's a tic-tac-toe products game, an abundant numbers game. I would do this as more of an extension for kiddos who are can be pushed a little bit more. You want to make it a little bit more challenging for them, because it's not, this is the only one that wouldn't be part of grade 4 curriculum, but it's a great way to dig deeper into what is grade 4 curriculum. So it's not like it's grade 5 or grade 6 curriculum, it's just a really deep dive. So you could use that one as an extension. And then I added some possible assessment questions at the bottom. So things that you could put onto an assessment. So the first one is talking about, do you agree with all prime numbers are odd, or disagree why? Gemma says 1 is a prime number. Do you agree or disagree? So those should be fairly simple if you've been exploring that lots. But then C talks about connecting it to time. Well, if you've never done this kind of connection to time before, what a great opportunity for students to demonstrate excelling understanding. A blue light flashes every 8 seconds, a red light flashes every 12 seconds. When do they flash together? Well, again, that's a multiple question. So a great one for assessment. And then here's a burgers and burger buns question that you can use as well for multiple. So I just threw a couple in there, and I linked where I got them off the internet as well. So lots of stuff in here. Now this is lots of pages. So the beginning is the outcomes that are addressed in there, and then the outcomes for each of the steps, and then the instructions for each of the steps that you can use. They are scripted in here, as you know, though. For me, it's not about scripting you, it's about so you know what my goal was in order to dig into that. But you need to make it your own. You need to figure out where your kiddos are at and where you need to move forward with them. And there's lots of opportunities for you to dig deeper in these. But keep it simple to start. Start with really small numbers and throw a bigger number at them to see how they do with that. And that could be considered excelling as long as it's within grade level. Because the thing to remember about excelling is it's still within grade 4 level expectations. But you just haven't taught it to them, or you haven't asked them that question in that context before. Those are your 2 ways to differentiate excelling from proficient. But you'll notice when you're looking at your long-range planning document that most of these outcomes are lighter shaded in October. So I picked them, so it's lots of opportunities to play and dig and formatively assess and worry about summatively assessing in November or December. Give them lots of time, because this is going to help them really master those multiplication facts through experience rather than rote memorization. And we know that when kiddos build it through experiences in a lot of different contexts, that's when they'll master those facts rather than rote memorization. So I'm hoping that was really fast. That was me talking really, really fast, but hopefully you found that beneficial. I will copy these all into that. When you look at your calendar invite, you should see the notes document. I will throw all of that in there, but I will also throw this somewhere on the PLC website. I'll find a spot for it on there, and then into the grade 4 shared folder as well. So you'll be able to find it in lots and lots of places. If you have any questions, feel free to unmute and ask me. Otherwise, if you have to go, I look forward to hearing from you on how that went. And if you have an idea for the next little Google Meet like this, feel free to email me those too.